Now we will see the rectangular window. The n-point rectangular window WR of n is defined as WR of n is equal to 1 when n ranges from minus n minus 1 by 2 to n minus 1 by 2. Otherwise, it is 0. Alternatively, it can be expressed as WR of n is equal to 1 when n ranges from 0 to capital N minus 1 and otherwise it is 0. Now the rectangular window can be defined by this equation, and we can say for odd values of n, this term can only be used for odd values of n, but this method, that is these equations, can be used for both odd and even values of n. So now the frequency response, or we can say the frequency spectrum of rectangular window WR e raised to j omega is obtained by taking the Fourier transform of rectangular window sequence WR of n. So we obtain the final term, that is WR e raised to j omega, that is equal to Fourier transform of WR of n is equal to sine omega n by 2 upon sine omega by 2. Now you can prove this equation. You can prove it like WR e raised to j omega is equal to Fourier transform of WR of n. That is, by definition of Fourier transform, summation n is equal to minus capital N minus 1 by 2 to n minus 1 by 2 e raised to minus j omega n. That will be summation n is equal to 0 to n minus 1 e raised to minus j omega n minus 1 by 2. Now we will separate these terms, that is this and this term. So after separating, we get summation n is equal to 0 to n minus 1 e raised to minus j omega n into e raised to j omega into n minus 1 divided by 2. Now what we will do, that we will make this term, that is it doesn't contain small n. So we can separate this term such as e raised to j omega capital N minus 1 by 2 into summation n is equal to 0 to n minus 1 e raised to minus j omega n. Now using the geometric series sum formula, that is summation n is equal to 0 to capital N minus 1 c raised to n 1 minus c raised to n upon 1 minus c. So it will be e raised to j omega n minus 1 by 2 into 1 minus e raised to minus j omega n upon 1 minus e raised to minus j omega. Now e raised to j omega n minus 1 divided by 2. Now we'll multiply and divide by e raised to minus j omega n by 2, or we'll separate the terms. So it will be like e raised to minus j omega n by 2 into e raised to j omega n by 2. This is equal to 1, that is this term. So we can take common terms out. Minus e raised to minus j omega n by 2 into e raised to minus j omega n by 2. That again makes this term. The whole divided by e raised to minus j omega n by 2 into e raised to j omega by 2 minus e raised to minus j omega by 2 into e raised to minus j omega by 2. So after taking the common terms, we finally get e raised to j omega n by 2 into e raised to minus j omega by 2 multiplied by e raised to minus j n divided by 2 into e raised to j omega n by 2 minus e raised to minus j omega n by 2, and divided by e raised to minus j omega by 2 into e raised to j omega by 2 minus e raised to minus j omega by 2. Now all the terms get cancelled. So finally we are left out with these terms. They are equivalent to sine of omega n divided by 2 divided by sine of omega by 2, and this is the required result. Thank you.